A 30-foot ladder is leaning against a building. The ladder is sliding so that the bottom is moving away from the wall at 2 feet per second. At what rate is the top of the ladder sliding down the wall when the ladder is 24 feet above the ground? We'll start by sketching a diagram. Let's represent the wall as a vertical line, and then the ground, and then this ladder will be our diagonal. And we know that the ladder is 30 feet long. We can label the ground as X and the wall as Y. We know that it's sliding away from the wall at 2 feet per minute. And what we're interested in is at what rate is the top of the ladder sliding down the wall. So this is the part we're looking for. Labeling what we know, dx dt is 2. dy dt we do not know, and we are specifically concerned about what dy dt is when y is equal to 24, when it is 24 feet above the ground. Next, the equation that we're going to start with, since we're dealing with a right triangle, will be the Pythagorean theorem. X squared plus y squared equals z squared. From here, we need to see if there's anything we can plug in, any given information. X is consistently changing as the ladder slides, as is y, so we can't plug in anything there. But z, the length of the ladder never changes, so we can replace z with 30. The equation now is x squared plus y squared equals 900. Once we've filled in the equation with our given information, we can then differentiate that equation implicitly with respect to time. The derivative of x squared is 2x times dx dt, using the chain rule. The derivative of y squared is 2y dy dt, using the chain rule. And the derivative of 900 is simply 0. Next, we can plug in given information. 2 times x, we don't quite know what x is yet. Dx dt, we do know, that's the 2, the rate at which the ladder is sliding away from the wall, plus 2 times y. Y we know to be 24 at a specific given point in time that we're curious about. Dy dt is what we're looking for. So now the question is, how do we find x? Well, to find x, we need to do just a tiny bit more information. Using the equation from earlier, the Pythagorean theorem, we know that y is 24 and z squared is 900, so we can now find x squared. X squared is equal to 900 minus 24 squared. 24 squared is 576, so x is equal to the square root of 324, which we know to be 18. Now that we have x, we can replace it in the derivative equation and simplify this equation and isolate dy dt. 2 times 18 times 2 is 72, plus 48 times dy dt, still equal to 0. Subtract 72. And then finally divide by 48. And we get negative 1.5 feet per second. the rate of change in y, or the rate at which the ladder is sliding down the wall at the moment the top of the ladder is 24 feet above the ground.